In this video, I'll be going over our practice problems for CFA 1. So question number 1, notice how we are solving, and also notice with this equation that we're solving that there is no x term or there is no b, which means here I'm just going to go ahead and go through and solve for x using square root method. So I'm going to subtract 51 because we're solving for x, so opposite inverse operation. Now I have negative 36 is equal to 3x squared. Now I'm going to divide both sides by 3 because you're still multiplying that x term by 3 here. And x squared is now equal to negative 12. Now notice by doing our last step here, right, taking the square root, you're taking the square root of a negative value. Because now remember, when taking the square root of a negative value, there you have negative 1, which is I. So we do need I in our final answer. So I'm going to mark off A and B. When you simplify the square root of 12, here I could break that down to the square root of 4, right, times square root of 3. Square root of 4 is 2, so 2i radical 3. So that's why the answer here is C. Now, question number 2, we do have an x term, so we do have a trinomial, but it has to equal 0. So I'm going to add 21 here first, right, to get our quadratic equal to 0. And I've got x squared minus 8x plus 21. Now, I cannot solve this by factoring, and if I look at my answer choices here, right, I could either use completing the square or quadratic formula. I'll go ahead for this problem use quadratic formula to solve, and I'll start with a discriminant. Remember, discriminant is b squared minus 4 times a times c. Remember, that is what's inside of the radical. So b, remember this is your a, b, and c values. So b is negative 8, so negative 8 squared minus 4 times a, where a is 1 times c, which is 21. Now I've got 64 minus 84, which gives you a discriminant of negative 20. Now notice and remember, when you had a discriminant that was negative, that means you have no real but 2 imaginary solutions. So we know we're going to need I in our final answer. So I'm going to mark off C because I don't have I in my final answer here, or imaginary. Now I'm going to go ahead and continue. Remember, quadratic formula is negative b plus or minus the square root of our discriminant here, right? The b squared minus 4ac over 2 times a. So now I'm going to continue and plug everything in. So x is equal to negative b, which here, remember, right, is negative 8 plus or minus the square root of negative 20, our discriminant, over 2 times a, which here in this case is 1. Now notice as we're simplifying, we do have 2 negatives here, 2 negatives making a positive. So this here is now going to give us positive 8 plus or minus. Now see how we're taking the square root of negative 20. So now remember, right, we are going to need I because the square root of negative 1 is I. Then the square root of 20, well, here I could break that down to perfect square factor of 4 and 5. Because what is the square root of 4? 2. So 2i radical 5. We have 8 plus or minus 2i radical 5 over 2. But now notice we can divide both values here by 2. So 8 divided by 2 is 4, plus or minus 2 divided by 2 is 1, so that's just I radical 5. So that's why here the answer is B. Question number 3, we are solving, but we're going to focus now on that completing the square. So remember, when completing the square, we need to first organize and just have our x terms together. That means I need to move my constant, this negative 28, over to the other side of our equation. So I'm going to add 28 now to both sides of the equation to start completing the square. Now I've got x squared plus 12x plus my blank, right, to complete the square, is equal to 28 plus blank, right, to complete the square, because whatever we add to one side, we add to the other side. Now we always took our b term when in this case, which is 12. And then we're going to take that 12, we're going to half it and square it. So now half of 12 is 6, and 6 squared is 36. What we add to one side, we add to the other side. So now when I write this as my perfect square, notice how we need x plus 6. We could use the pattern of what was inside, or if you think about it, right, 6 times 6 is 36, and 6 plus 6 is also 12. So that works here as well. Is equal to 64. Now that I'm at this part here, right, x plus 6 to the second power is equal to 64. Now I can solve. See how x plus 6 is the whole being raised to the second power. So I need to first take the square root before subtracting 6. So when you take the square root, right, their inverses cancel out. And x plus 6 is equal to plus and minus 8. So square root of 64 is plus or minus 8. Now we can continue solving and subtract 6 from both sides. So x is equal to negative 6 plus or minus 8, which here we can continue solving because that means we have negative 6 plus 8 and negative 6 minus 8. That means here I've got x is equal to 2 from negative 6 plus 8 and negative 14 from negative 6 minus 8. So that's our two answers here by completing the square. Then number 4 is review. Notice how there is, again, no x term, right? So we have no x, there is no b. But we are finding, or we're factoring the sum of two perfect squares, because the square root of 9 is 3, and the square root of 121 is 11. But because it's the sum, we do need now I in our final factored form. So this would be 3x plus 11i, and then 3x minus 11i. For our next question here, we are just factoring. We're not solving, just factoring. I do notice my a here value is 5, so I cannot do the table yet. But can I divide all three values by a common factor? No. So that means now, because there is no GCF, we're going to go through bottoms up, where we multiply our a times c, the first to the last. So really, we're going to now go through and factor x squared minus 14x, but plus 40. So now, what numbers multiply to get you 40 and add to get you negative 14? Negative 10 and negative 4. But remember, right, is this our final answer? No, because in bottoms up, whatever your A was, whatever you multiply by, now you have to make sure to divide by 5. So now 10 divided by 5 is 2. So x minus 2. Now I can't divide 4 by 5 evenly, so bring that 5 bottoms up. 5x minus 4. So that's why here the answer is B. Now, question number 6, we are solving. So make sure in the end you switch the signs because we are solving setting equal to 0. And our equation's equal to 0, so we're good to go. I notice again that my A is 3 here, so I can't use the table, right? And I don't have a common factor to divide by. So because there's no GCF, we are going to go straight into solving using bottoms up. So again, x squared minus 2x, but now minus 24 is equal to 0. Now we can go through and factor what numbers multiply to get you negative 24 and add to get you negative 2. So here you should get negative 6 and positive 4. They will multiply to get you that negative 24 and add to get you negative 2. Remember, still equal to 0. Now, does this mean this is our answer? No. So now I need to go through here and still whatever we multiply by, now we need to divide by 3. Now I've got 6 divided by 3, which is 2, so x minus 2, and then bottoms up, 3x plus 4 is equal to 0. Now that we're solving, x minus 2 is equal to 0. So that means if x minus 2 is equal to 0, then x is equal to positive 2. And again, that's from solving. So now I know x is positive 2. So that means truly from test taking, the only answer is A. But I'm going to still go through so that you guys can see that the other solution is negative 4/3 here. So here I've got 3x plus 4 is equal to 0. And that means here I would subtract 4 to solve for x. 3x is equal to negative 4 and divide by 3. There's your negative 4/3. Then another pattern is, here's the fraction from when doing bottoms up. So if I have a positive 4/3, then when solving I need negative 4/3. In the next problem here, we are simplifying our radical, but notice we are multiplying our final answer by 1/3. So we're multiplying by 1/3 here, so keep that in mind. We are also finding the square root of simplifying the square root of a negative value. So here we need that to be positive, which is the same as -1 times 45. And again, the square root of -1 is I. So I already know that D is not my answer because there's no imaginary unit. As we simplify the square root of 45, this is the square root of 9 times the square root of 5. The square root of 9 is 3. So 3i radical 5. However, is this our answer, which is B? No, because remember, we are multiplying by 1/3. 1/3 times 3 is actually 1. So it's just I radical 5 that you're left with, which is A. Question number 8, you're actually subtracting. This is 8 minus the square root of -16. Well, here the square root of 16 is 4, right? So square root of 16 is 4. So that means the square root of -16 is 4i. Now I have 8 minus 4i. Now, can I continue in simplifying this? Well, no, because 8 is real. -4 is imaginary. So this is the imaginary part, -4i. So these two values here, they are not like terms in our complex number. So we're going to leave it our answer with C. Number 8, whenever it's asking, the question's asking how many solutions a quadratic has, we are going to use to calculate the discriminant b squared minus 4 times a times c, where here's my a, b, and c. Notice too that our equation is equal to 0, so I can set it the values of a, b, and c. So b squared or -10 squared minus 4 times 1 times 25. Now here, I'm just going to go through and solve this, but this is 100, positive 100, because negative times negative is a positive, minus 100. Well, I get a discriminant of 0. Whenever you get a discriminant of 0, that means you only have one real solution. So again, remember the discriminant, if it's 0, you have one real. If there's two real, then the discriminant is positive. If you have no real because you have two imaginary, then the discriminant is negative. You will never have one real and one imaginary. Number 10, notice we are solving for x, but I do need to distribute my x value. So x times x is x squared, and x times 6 is 6x, which is equal to 16. Now remember, to solve our quadratics, they have to equal 0. So I'm going to subtract 16 from both sides. Now I've got x squared plus 6x minus 16. Don't subtract anything, the 16 from anything, because they're not like terms. Notice how 6x has an x, but -16 is just a value constant here. Now, because x squared here, the a is just 1 by itself, we can go through to the table. So what numbers multiply to get you -16 and add to get you +6? +8 and -2. Notice how those two values will multiply to get you -16 and will add to get you 6. But is this our answer, +8, -2? No. because remember, we are solving. This is all equal to 0. That is x plus 8 is equal to 0. That is x minus 2 is equal to 0. That's why we switch the signs here, because when I'm subtracting 8 to solve for x, there's my negative 8. So I know it's not A or C. Then here, if I'm subtracting 2 from x, you would add 2. And there's your positive 2. So that's why the answer here is B. In this next problem, we are just simplifying, but keep in mind we are combining and we're also multiplying. I'm distributing here 6i. I'm going to first go ahead and distribute as this was 6, but 6i. So 6i times 5 is 30i. Then here I've got 6 times negative 2i, which is negative 12. But notice how we had I times I, which is I squared. Then remember, I squared is always negative 1. So notice how two negatives now make a positive 12. So 12 plus 30i. I switched it so I could write that in standard form. Then plus 3 plus 10i. Now I can just combine my like terms. Here I've got 12 plus 3, which is 15, and 30i plus 10i, which is 40i. Then number 12, we are dividing, but again, first notice how the denominator is not in standard form. So I'm going to go ahead and rewrite this. So I'm going to simplify 7 plus 2i divided by 6 minus I. Now we can identify what is the conjugate of the denominator, where we change the imaginary part. So if this is negative I, we're now going to use 6 plus I. Remember what we do to the denominator, we do to the top to the numerator. Now notice here we are multiplying in our numerators two binomials. So we do need to set up box method. So 7 and positive 2i and 6 and positive I. 7 times 6, 42. Here, 6 times 2i is 12i. 7 times I is 7i. And 2i times I, 2i squared. Then remember, I squared is always negative 1. So 2 times negative 1 is negative 2. So really, we have negative 2 here being replaced. Then here I do have like terms to combine. We have two imaginary. So 12i plus 7i is now 19i. Here, so now combining like terms again, 42 minus 2. So 42 minus 2 is 40. So in our numerator, we have 40, and don't forget your imaginary, plus 19i. Then we did a pattern in the denominator where I could multiply. So 6 times 6, our real part, 6 times 6 is 36. Then here, negative I times I, negative I squared. Then remember, I squared is always negative 1. Notice two negatives make a positive 1. So 36 plus 1 is 37. So here's our final answer. Or remember, you can separate this. So this is 40 over 37 plus 19 over 37i.